Okay, good. I hope you can hear me. If not, please let me know. I have my screen share, so the organizers can reach me on the phone, if so. Just mentioning before I speak to my screen for 50 minutes without you being there. Yeah, it's a shame I can't be there, but yeah, it wasn't possible for multiple reasons. So this is next best thing, I think. But yeah, I would really have liked to come back to Israel. Yeah, but here we are. But that doesn't stop me from at least telling you about yeah, dynamic Java from my location here in Oslo, in Norway, where I live and work. I'm Rafael. I'm an open source developer. Possibly this was told to you already by the introduction. I create a library called Byte Buddy, which is my ticket to Java fame, so to speak, which is used in multiple libraries and throughout code generation and Java agents. And the topic of this talk basically is to demystify this a bit. I know that code generation sounds very academic, and it's yeah, maybe something that seems very obscure to most people. And my hope with this presentation is that at the end of this talk that you sort of understand what it is used for, why it is used, and how you can use it if you want to learn more, and where to start. So, but what I find always the most important part about code generation is to explain why it exists. And for this purpose, I'm basically introducing a very simple security library, which deliberately looks a bit like Spring Security, for example, or other similar libraries, where we want to implement method level security, which basically means that we have an annotation which has a string property called user, and then we have a user holder, just a global store for specifying what user is currently logged into the application. And that starts out with an anonymous user. Then we will have a service, for example, that is having this very important panic button, for example, that deletes everything, clears the storage, maybe for debugging purposes. And of course, we don't want to this method to be triggered by accident. So we want to secure it very narrowly. This is good security. We don't just have some check on the outer rim of the application. We want to be sure that this method can only be invoked if an administrator is logged in. And the question now is, of course, if you were a Java developer, and you probably are a Java developer, how would you implement this framework, or how is Spring Security, for example, implemented? So what we need to do is that we kind of secure the method when it is invoked. And the problem here is, of course, that if we have a framework that is supposed to being able to secure any class, how would that class be secured? Because the problem here is that the service doesn't know the framework, but the framework doesn't know the service, right? So if you write Spring Security, you just have to implement this interface somehow, the framework interface, but you cannot know that this particular service will be the target of your application. So kind of this inversion of responsibility is something that we normally cannot circumvent in Java. At least not at compile time. That's the whole trick, right? At runtime, these two classes will be on the same class path. And if you implemented the framework as part of the application, you would, of course, know how to manually secure the service, right? You would know how to check the single static field from your method. And you could, of course, then just inline this. You just, instead of having the code there, you would have like a user holder user check to see if it is admin, like in the annotation. And if it's not, you throw the exception, meaning that you will never reach the actual code of this method. You have now successfully secured the method with authentication. The problem being, though, that you will have hard-coded this, and if you forget to change it, and if it's like tests set up, you will still have to manipulate this global state. It blows up your application in complexity in a way that you normally don't want to. Runtime code generation, as you will learn in this talk, will allow you to change this class, either at build time, for example, or via an agent. Java also knows something called annotation processing, which somehow allows you the same thing. Another more common approach, though, and this is the approach Spring Boot and most frameworks use because it requires less build time setup or runtime setup, is list scope substitution. Any service can be subclassed by anything else. And then in the service, you can override any method, making sure that you will first check the user again and then throw an exception if the user isn't logged in, and then only invoke the super method if you have invoked, if you are logged in correctly. And as you know, you cannot invoke a virtual method in Java without invoking the sub method. So it is impossible to actually invoke this code directly. So you have reached the same thing as long as you make sure that you never instantiate your service directly. And Spring Boot, for example, will do this for you. All your Spring Boot beans will be extensions of your actual classes to make sure that all the annotation handling is taken care of. And basically now you already know the magic that is behind and what we want to do here, right? But how does this work, and why this is a Java thing somewhat? And it is a Java thing because Java is a dynamic language in many ways. It's compiled statically, you know that, of course. You write your Java code and you run Java-C, but Java code is only compiled to Java bytecode and the class file format, where the original code in Java at least and the bytecode that is compiled to is pretty similar. And that's also gives a possibility to implement different languages on the JVM, like Scala, Groovy, JRuby, Kotlin. They all will compile their languages down to this bytecode format. You might have heard of the Coffee Babe byte magic, byte value that is in the beginning of every class. That's all that's needed. Oh, just pictures. I'm still online. That's good. Saw my phone. So basically meaning that all these languages will in the end be the same thing. And Java and Java bytecode are pretty similar. Scala, for example, is taking it much further. But in the end, essentially, it's still a pretty straightforward thing. The Java bytecode itself is at runtime, it's interpreted. So basically, it's running instruction by instruction. But this is only for a short time. Once a method is used a lot and invoked a lot, the very famous JIT compiler will kick in and optimize the code in a way that makes it very fast still, despite this very primitive bytecode format. And the whole reason that we can do this in Java, for example, but we cannot do it in languages like C or in Go as easily, the dynamic code generation, is that the optimization is delayed until runtime. The JVM will create a runtime profile, JIT optimize the code, and it doesn't really matter if the code is dynamic or static, because the code generation will only take some additional startup time, but after that, the generated code will run as quickly as possible. And my library, Byte Buddy, is basically doing exactly that. It generates bytecode the same way the Java compiler generates bytecode and generates class files the same way the Java, Scala, Groovy, JRuby, Kotlin compilers are doing that. The big difference is, however, that it is running it's creating class files, but it's also reading class files. To some extent, the other compilers are doing this as well, but they only mostly read method signatures. So they're just interested that another class has these certain methods defined and can invoke them. Byte Buddy, however, is capable of also parsing existing method bodies and to modify them. And then the other difference to a regular compiler is that it is running on the same JVM that is executing the code. So basically, Byte Buddy has the capability, and it does this a lot as well, to modify itself. This is why Byte Buddy still runs on Java 5, but the privilege of creating a Byte Buddy a code generation library is that Byte Buddy can modify itself at runtime to optimize for newer JVMs. So it doesn't really matter as much as it does with other libraries, because Byte Buddy can basically optimize itself with new bytecode and class file features, depending on the JVM version it runs on. And that's the whole reason that the Java ecosystem has drifted in this direction. That's the whole reason that these kind of libraries are possible on JVM and they're not possible on all other platforms, right? Because if you, for example, had a head of time compiler that is very heavily involved, like the C language, then the generated machine code that C would generate would be fairly slow, so it wouldn't be attractive to use it. At the same time, you would also have to basically write machine code for the specific platform. Java bytecode, fortunately enough, is platform independent, so it's the JIT compiler's job to make it platform dependent, and this is happening after what we're doing. All right, but you can argue, isn't reflection meant for this, or with newer JVM versions, shouldn't you use method handlers and so forth? And sometimes, yeah, so there's nothing wrong with reflection. You should use that when it's appropriate. the same, or like rather, method handle lookups and method handles in your JVMs, even though reflection is retrofitted on method handles anyway. So performance-wise, it's not that much of a difference. And actually, modern JVMs don't make a difference much in terms of performance if you use bytecode generation or reflection either. There's still some corner cases, but if you have to optimize for that, you already know much more than I can teach you in this presentation. So I'm not going into this, but the idea with reflection isn't that you can write a framework like Spring Security. For reflection just is about interacting with code. But if we want to basically mimic types, so basically create a service that is the secured service that I showed you before, reflection cannot help you with that, because you would have to create wrapper types. And with wrapper types, you would lose your signatures and your type safety. The beauty of code generation is that you can keep the type safety and have the reflection-ish approach to it, right? So, and fail fast is another thing. So with code generation, at least when you create the code, it will fail fast. If there's something wrong with reflection, you often get runtime errors deep into your stacks and long into your application startup. So I tend to avoid it if I can with frameworks that need it, right? And of course, you can do it yourself. As I mentioned before, this is a perfectly fair solution. Often it's a good solution. If you have few needs for something like this, you should code it out. But if you want to be certain that your framework library remains maintainable, then declarative programming with annotations is a nice property, because you can navigate your code base, you can find annotation usage, and you can be sure that it works, and you can split up test environments and production environments in different ways and configure things in a different way, right? All right. By the way, I like to mention that as well. Most other languages have features like that. Let's take JavaScript. JavaScript is a fully dynamic language, and JavaScript has sort of annotations. You can use annotations, and then using toString on objects, you can parse them out. There's frameworks for JavaScript that do that. So you could do the same thing in JavaScript as we do in Byte Buddy. But the beauty of JavaScript, and that's the advantage of dynamic languages, is that like dynamically typed languages, is that you can just, if you call a method delete everything, you could just dispatch it directly. And that's what frameworks in JavaScript like React do, right? If you invoke a method of your own object in React, you wouldn't invoke that object actually. You would normally invoke the React engine, which then gets a metadata structure telling React that this method was invoked, and it can invoke the actual method and track state in between, and then afterwards it can update the front end, for example. So this isn't something that is particular to Java either. It is very, very common in dynamically typed language. However, in Java, the beauty is that you get both. You can have the type safety, and you still can do all the things that JavaScript offers you due to its dynamic typing. So with code generation libraries, you can basically unlock all this potential that other languages often claim they have, and other languages don't. Yeah, so-called duck typing, right? Due to that, and most of you might know that, or will likely know that from before, is that code generation on the JVM is everywhere. I mentioned Spring Boot, creating beans by subclassing. The same goes for Hibernate. How do you Hibernate objects, update and read from the database lazily, right? Hibernate will also create a subclass of all of your bean objects and then override the methods. And Hibernate actually does use Byte Buddy for that. And so like if you're calling a getter that returns a list in Hibernate and you have lazy loading, then this method will not just return the field like it looks in your Java code. Hibernate will have create a subclass that then goes to the database and reads that list of properties with the current connection. With Mockito, same thing, also uses Byte Buddy. What is a mock? A mock is basically also just a subclass that is overriding all methods and doing nothing by default. Or it will, of course, call the Mockito engine. If you configure a particular answer, it will just return that stub object that you have provided, or it will throw the exception that you provided. And it will, of course, record the invocation if you want to verify it afterwards. And modern versions of Mockito don't do this anymore. I'll get into this later. But like in the past, this was why Mockito didn't support mocking final objects. no subclass for final objects, final classes. So we couldn't mock it. The same goes for final methods. It is possible now today, and you might already guess how it is, but I'll take that when we get there. All right, but I don't want to teach you Java bytecode to the full extent, because that is an exercise I claim you have to do yourself in your own speed while practicing. But I want to show you how it works still, because I think it's useful to understand the engine you all use, and maybe also even being able to see bytecode. Actually, if you have a compiled class, you can use the Java P tool that is shipped with every JVM to inspect bytecode, as you will see it now. So, but the easiest exercise to learn bytecode, I think, is to just translate a single method from Java code to Java bytecode. And the first to know then is that Java bytecode is a stack machine, or models a stack machine. This comes from the old days where Java was used mainly for applets. And the advantage of stack machines compared to register-based machines is that all stack instructions have an implicit target, which is the top of the stack. And if you're loading applets dynamically over the wire on slow modem connections back in the days, it was an advantage to not having to specify the register for every instruction. So the bytecode would be more compact and would load faster. That was important back then. Today, it's irrelevant. It's kind of archaic, actually, but it is what we have. And I don't think this will ever change, because this would have a huge impact on the entire ecosystem. So there is some legacy, but it doesn't matter, as we have a JIT compiler, which of course translates all bytecode anyways, if it is important. Right. So what does a stack machine do? Like 1 + 2, if you remember your computer science classes, if you not have studied something else and came from across, it pushes something on the stack and pops something off the stack. So 1 + 2 in stack language is number 1, push on the stack, number 2, push on top of the stack. I add now, third instruction, pops 2 values off the stack and pushes back their result, their added result, which is 3. We miss one thing, the return. And this pops the value off the stack and returns it to the method. At the end of any Java method, the stack will be empty. So this is how Java bytecode looks like. This is how all bytecode of all languages looks like. If you want to ever create your own Java JVM language, this is what you will have to emit at the end. And you already can see, like, there's an I in front of every instruction. That's because it's an integer. If you use longs here, it will be lconst 1 and lconst 2 and ladd and lreturn. So it's even that similar, the bytecode in the Java language. It's still typed, right? So you have to be aligning with that. And there's a huge discussion what happens with value types in the future and so forth, how this bytecode format will evolve. This is kind of the problems people try to solve here. Okay, so of course, these names are not what's in the class file. In the class file, you will have bytes. And that's why it's bytecode, because every instruction is represented as a byte. So there's a maximum of 256 instructions in the Java language. Right now, I think it's a bit over 200 that are used, but new bytecodes, those so-called opcodes, are introduced fairly carefully. So they won't run out quite quickly. Right, so if you have this Java code and you compile a class, you can open your method and you can basically find the Java virtual machine specification, which mentions what means what. You will have the first bytes will be Cafe Babe, as I mentioned before, and then it will have like the fields and so forth and so forth. And then you will somewhere in this class file, if you get a hex dump, find these 4 byte instructions if you compile it directly as in this method. Right. And of course, there's frameworks for bytecode manipulation. Byte Buddy itself uses ASM, which allows you to emit bytecode directly. And you can basically just do that. If you wanted to create this method, you could create it like this with a visitor API, and you could use the tree API, which creates nodes as well. And then you can do that. And you can already guess how would you now manipulate bytecode. You would read or deserialize the class back to nodes, for example, and then you would switch out one node and serialize it back to the class file. So all you need to do to manipulate bytecode is to basically look up this table of bytes and find the byte that you're interested in and switch it out. Of course, Byte Buddy tries to make it more convenient than that, because the disadvantage with bytecode manipulation like this is that if you switch out the wrong byte to the wrong value, your JVM will just crash and you will basically not be able to load your file, and you will get the dreaded verification error, not even an exception, which crashes most machines, right? So Byte Buddy tries to make it safe to do that without using ASM, but you're still using ASM just indirectly. Right, this is basically what I just mentioned. Also, so the problem with bytecode itself, it's a little expressive. It has very few high-level instructions, especially when it comes to control structures. It still uses go-to statements for everything, for example. So a loop is just a label and a go-to instruction that jumps back based on a condition. And even the condition itself is a go-to instruction that just jumps over the loop. Its last go-to instruction. So it's easy to get it wrong. So in generally, even I myself try to not write bytecode by hand if I don't have to do it. And as I said, like the stack metaphor is a bit outdated. It's nothing. If you work on a big team that a lot of people still know, young developers learn more fancy tech than the good old state machines that were very popular once upon a time. Then you also have a lot of manual work. It's not only what I showed you, like all these jump instructions need to add stack mat frames, for example, mentioning what's on the stack on every go-to instruction. And you have to compute the operand stack sizes and so forth and so forth. Because for the interpreter, all this metadata is still mandatory. All right. And also versioning issues. ASM had some old versions that are still around, unfortunately, which broke a lot of API. So Byte Buddy also tries to avoid that. All right, so how does Byte Buddy look like? Some of you might have seen it, but basically it tries to be as similar to the Java language as possible, and it defines a DSL that allows you to subclass, for example, or to redefine classes. And the easiest Hello World example looks like this. You just create Byte Buddy, which is the API entry point for basically everything. Then you take it from there, letting your IDE complete your methods. And you say, all right, I'll subclass object, which is implicitly the subclass supertype of any object that doesn't have one explicitly. Then you say, I want the method that is named toString. There's only one, so this will work here. And then I'll intercept it by returning the value hello world and make this class, and then I'll load it into the current context class loader. And then I'll get the loaded class, and this class object you see there, this type class you will have seen, this is just standard Java reflection. So now we create a new instance and invoke the toString method, and we'll actually tell you hello world. You can copy paste this in your IDE yourself and yeah, see if it works from there. Oh, yep, I added color once upon a time. Of course, this is not very fancy yet. Creating a fixed value can be handy sometimes, and it's very efficient, but it's not normally what you want to do. What Byte Buddy also has, which is a rather popular concept, is method delegation. So this is a static import method delegation .to, but here it's imported my interceptor. So this is the new bit here. And then my interceptor will just define a single static method. And what it will then trivially do is it will just invoke this method. And this still returns hello world. This is the same result as before right here. But now you can set a breakpoint here if you want to. And the last bit you kind of have to understand is that what Byte Buddy tries to do and tries to help you with is that it allows you to specify parameters that are the things. So because the best way of creating bytecode, in my philosophy at least, is to avoid it at all costs, and basically just providing the glue code between your code and the user code, and making it as efficient as possible to glue these two bits together. Because you will just use your code. If something fails, it will fail in your code. You will be able to set a breakpoint. You will have a meaningful stack trace. And I think this is why Byte Buddy also became sort of successful, because this philosophy is convenient and it is intuitive for most people. So that was kind of the change that I made compared to old still around bytecode libraries like JavaSys, where you often compile strings, for example. And this is a good approach too. It's very powerful, but it is hard to maintain in my eyes. And Now you might already guess how Spring Security can be implemented from here, right? How would you implement your own Spring Security? Now you get the origin, which is the method that is actually invoked, which is the toString method of the subclass you created. Now you can read the method's metadata. You can check if there's an annotation with secured on this method. You can read the user and you can basically throw this exception from here. And then invoke the original method. This is, of course, also possible using parameter injection, only if you want to, right? So this is basically what you can do, right? So you can do super calls and default calls and so forth and so forth. You can get specific arguments. You can get all arguments. You can get proxies. That's basically, I'm not going through all the things. That would be a talk of its own. And again, I think it's easier to do this on your own terms and own time. But basically you can get hold of anything that is also provided to the original method. Right. So basically this dependency injection. Then what I mentioned here, also a nice property of annotations is that if your user code and is on a different class loader, and I don't want to get too deep into class loaders, but if there's like OSGI or these things where basically namespaces are shielded and you cannot see all libraries of your own dependencies, then the annotations won't fail. Annotations that aren't loadable for some reason will just be invisible. That's kind of defined in the JVM specification. So it will also work with all these environments and other libraries like cglib, which inject their own interfaces into proxies, won't work again. So that was a huge issue also with the module system, which is basically just doing something similar with visibility boundaries. A little known, the JVM supports hot swapping code. Hot swapping code means that you can take existing code that is already loaded and change it. So this example here, you have a class foo that returns bar, and then your code somewhere has a instantiation of foo. You can use Byte Buddy to redefine foo, take this method bar, and then using a so-called Java agent that is already installed. I'll show you how this goes later. You can still take this method bar and intercept it to return the value hello world. Keep in mind that this middle bit here might not be very obvious, but it can drive your colleagues insane if you write code like this, obviously, because they will basically just have foo, new foo.bar, and it will return hello world. And if they set a breakpoint in the return bar method, then it will never trigger because you have changed the code in the class loader directly. So that's possible. But Hotspot doesn't allow you to do things like introducing new methods in the class, and it's kind of on its way out. Hot swapping was more of a debugging feature for a while. There was a JEP to enhance it, but this JEP isn't followed up anymore, and I don't think it will ever be followed up, unfortunately. But it's just not a priority feature, and people can do well without it. So I think we can just. It's nice to know that it exists, but it's not, on the rising end. A more convenient way of doing this, a more standardized way of doing this, is Java agents. Java agents, basically, we want to do the same thing again as with Hotswap, but Java agents are installed at application startup normally. So a Java agent is just a jar file in a way that has a different sort of entry method. You all heard of main. There's two additional entries, one is called pre-main and one is called agent main. We'll look at agent main in a minute. So pre-main, as the name suggests, is a main method that is invoked before the main method, and it allows you to install a so-called Java agent. A Java agent is our class file transformer. A class file transformer is basically a callback that is invoked every time the JVM loads a class. And this is the second entry point in Byte Buddy, second out of two, which is the agent builder. The agent builder allows you to take a type and then transform it. So here we tell the Java agent the agent builder we want to instrument all types named foo and then transform them by taking the method named bar to return the value hello world. Same as before. Actually, it's the same DSL as before. So if you look at the Byte Buddy here, this is the same steps, the same types. That's important to me, at least. That it's the same because you don't have to relearn everything that you have learned with subclass transformation. You can just apply it to Java agents. So all you need to do now is you will take this jar, you add a manifest to it where you say pre-main, and then you point it to the class that contains the pre-main. If you then specify it on the Java command with -Java agent and then point to the jar file, it will load this. It will call the pre-main method. You could set a breakpoint there if you wanted to. It will invoke it, install the method, then it will invoke the main method thereafter, and the transformations that you have specified here will all apply. And yeah, now you can already guess if you're already thinking about approaches how to use that. If you think of, let's say, the open telemetry agent for monitoring code, all these APM tools, Datadog and so forth, they also use Byte Buddy. They use this very same API to hook into code and to intercept it. And normally, of course, you wouldn't change the return value of any method to hello world or so, but you would add some functionality. And to show a way of, there's blue, to show like a very simple approach to that, you could, for example, time method invocations. So let's say you want to print how long it takes to invoke a method, then Byte Buddy offers a convenience that wraps code around existing code, which is called advice. Advice in Byte Buddy has two methods. One method is called enter, and one method is called exit, and they annotate it with on method enter and on method exit, and they do exactly what you think it does. On method enter is invoked before the method that you target is invoked. And here we just take the nanotime of the system. And then on method exit, we take this nanotime there as a parameter, and then we compute how long it took to invoke it. So if you had this method bar and you would apply advice to it, it would basically take the enter method and copy it in here, in the beginning. And it would take the exit method and copy it first, like back up the result that we return. Then we would copy it in here in the end before it returns the actual result. And then here we print out what method it took how long to invoke, and what is a monitoring tool like Datadog doing in a way. It does that a bit more fancy, obviously. It records it to some Kafka queue and then shows it in the dashboard. The same goes with Zipkin or with OpenTelemetry. And they all use this very same API. The signatures don't look that different even. Of course, you can carve out a lot more functionality and so forth, but in this essence, you get what I mean, right? And again, we can use a Java agent. This time we take a so-called agent main, and now we agent main, meaning that we will be, I'll show you in a second, be able to invoke it even after we started JVM. And now we apply this advice, slightly different API to use because we want to decorate. We don't want to replace it this time. We want to decorate an existing method. So we just say like, all right, take all methods of type foo named bar and apply this advice. And if you now invoke foo bar, it will print you bar, and that it took a ridiculously long time for some reason to invoke it. Also, we have this here, agent main. We can say we want to retransform classes. So you can do this even after the JVM has been running for ages, because this time you don't put it on the command line. You can just attach it dynamically. I should have updated the slide because in the latest JVM version, this functionality is restricted. You have to now enable dynamic class file changes. Since Java 22, it's printing a warning. I think next Java version 23, this is not possible anymore. So this is something that's also going away. I mentioned that hot swap is on its way out, but nevertheless, you can still do that today. But otherwise, you could do it in a regular agent with a pre-main. And there's tons of agents out there that monitor your applications. But yeah, you can write them yourself if you want to. The technical bits aren't that hard. It's more like the recording and the dashboards. But yeah, it's all lying there right away. So, since dynamic instrumentation is on its way out, not dynamic, runtime instrumentation, increasingly more popular approach is to instrument your agents during build time. Byte Buddy also offers options for that, and this is, I would say, still rather uncharted space. Byte Buddy has a simple build plugin API. You can, for example, say, all right, I want to take, again, all net types named foo, and then I take all methods bar, return hello world. So again, the silly, obvious example. And then you implement just this API. Yep. And then you can just specify, for example, in your Maven that you want to use the Byte Buddy Maven plugin and transform and use the package simple plugin. By default, it will just check the current project for the plugin, but you can also just specify an artifact, group ID, whatsoever, and distribute your common plugin this way. And you can do the same thing as you would do with an agent, just that now you do it at build time. A very nice property of this as well, that it will work with ahead of time compilation, which is also coming to Java more and more, like with Graal, without any restrictions, because what you will do is you will transform your code during build time. And then basically just deliver a regular Java program to the ahead of time compiler and the Graal engine. And that's also kind of why people still call Graal not being standard Java, because it is having these restrictions about bytecode manipulation. But if more and more people move their manipulation to build plugins, this won't matter much more in the future. Same works for Gradle, of course, and different build tools that are out there. Of course, that's basically the downside of it. Like, some people like to use Bazel more and more. I have looked into writing a Bazel plugin for Byte Buddy, but rage quit after a while because it's just moving. It's like a typical Google product. Once I understand the API that it's deprecated, so I haven't bought it yet. And same goes somewhat for Gradle, but it's still keeping pace with me. All right. What's the idea of all of this? Yeah, why should you know this? Should you reinvent Java? And I would say, to some degree. A lot of applications are built around central infrastructure like Spring Boot and so forth. And often that's a good solution in my eyes as well. So often that's a good way of solving problems, but sometimes it is not. If you're especially write microscopic applications that shouldn't use frameworks, and then you want to still be able to monitor things, then especially Java agents that are custom made can be a good approach. You can use Java agents to manipulate code that is already executing. You can even use them to fix bugs in running applications. And you can basically take these central pieces out. Because if it's your central pieces, normally these central pieces will age not as well as maybe your domain code. And then removing them can be very painful. So especially if you have cross-cutting concerns, it can be nice to delegate them out and keep them out of your domain code. And that's kind of where you sometimes should realize that this is an option that isn't as complicated and complex as it seems to most people when they look into that. All right, so I'm wondering if this is my last regular slide. No, it's not. I'm mentioning Android. I already mentioned Graal. Android is a big step into the Java ecosystem, but as anybody who has followed the news on Oracle and Google arguing also understands, is that Android isn't regular Java. And basically this is what the big dispute is about. Java is a tool chain that creates Java class files, right? And this is the stack and JIT machine. That is that what we learned just now. Android has created a new format back in the days. That's the Dalvik virtual machine. Spoiler, it's not what's used anymore. But the Dalvik basically moved from the stack machine to the register-based machine. And it still has JITting though. The reason it does that is that basically for the same reason that Oracle, or not Oracle, but Sun introduced applets oriented stack machines back then. Stack machine should go quick over the wire back in the days. Android apps, on the other hand, they're loading the I/O isn't the problem that much anymore because it's already in the phone. The problem is that the app should be fast, quick. And as anybody with kids, the teenage years knows that apps are used for a few seconds and then the app is closed and switched and it's opened again. So they shouldn't take forever to compile, right? And the translation from a stack machine to a register-based machine, that's a very complex operation some way. The Java narrative is it doesn't make that much of a difference because you start up your server and then it doesn't matter much anymore. But for Dalvik, it does matter how much the startup takes. It's a much more central consideration. And that's why this change was made. Again, however, if you translate Java bytecode during installation, actually, back in the days with Dalvik, when you installed your Java app on the phone, it would translate all the bytecode once to the Dalvik bytecode format. And then it's, however, no longer standardized, right? Ironically, Oracle with Graal does something similar. But of course, then it's in-house and not too much said, but there's also dissonance about if that's a good approach within Oracle. But all in all, of course, it's a legitimate reason. But as a result of that, all the bytecode manipulation didn't work anymore. As a matter of fact, Byte Buddy has a Dalvik adapter that allows you to translate generated code from Java bytecode to Dalvik bytecode dynamically as well, but it won't allow you to redefine classes at runtime. Modern Android, however, uses the Android runtime ART, which is not only register-based, it's also ahead of time compiled. To some degree, the Byte Buddy approach still works, but it's even more complicated now, and it's less reliable and less performant because now most Android code is ahead of time compiled, and Byte Buddy cannot do as effective code. So using code generation now on Android implies a penalty in performance. So mainly it's still used for testing, but not much more anymore because of that. Yeah, the same arguments I had about not using code generation on C, for example. Right, but it's the way it goes, and it's a fully different API implementation of Java, and that's what the lawsuit was about somewhat. Can you just, take the API, the standard API, and replicate it? Is that legal? And we don't know if you follow the lawsuit. The only decision that was made in America, all the least, is that it's fair use. So the court said we don't have to decide if it's copyrightable. Just can say it's fair use, and then we don't have to decide the actual case. And again, that's only true for America, but there was no other lawsuit, and let's hope that things stay quiet now. It doesn't help us as developers, at least. All right. But now I'm at the end of my regular presentation. I know I still have 7 minutes left, which I thought I use for questions. And we can do that. I have some additional slides in a different document. So I'll just jump out of my slides. By the way, if I'm suddenly cut off, I'm Rafael, as I mentioned. Find me on Twitter, you find me on the net, you find Byte Buddy on the net. I have some other open source that you can find out about this. I'll just drop out of the full screen for a second. So now you see one of the organizers. I don't know if you have questions there on chat, or if I should just see if I can, because I have a more than 50 minute, the long, painful version. Let me see. I hope I have the right one here. We can look about a bit more in bytecode. Yeah, invoke dynamic. That's a fun one. So, what's invoke dynamic? Let me see here. So you all know, like bytecode now. In 5 minutes. Bytecode basically also has invocation bytecode instructions, and it's just another byte that says invoke a method, and now I'll give you a string in the sub bytes that you have to encode from this consequential details here, but of course you all know there's virtual method invocation in Java. This is the standard form. There's, however, also static method invocation. It's different if you what bytecode you use. And there's invoke special one.
אם יש מישהו שמעוניין לשאול את רפאל שאלה, שירים את היד ואני אגש אליו.
Superclass method, right? And you say, I want to do this special thing. It's a poorly designed bytecode if you ask me, but this is the third thing. And then we have invoke interface, has some legacy in how bytecode is modeled. Also not going to talk about it. Last one is invoke dynamic. And you might have heard about invoke dynamic and situation of lambda and so forth. So what does invoke dynamic do? So the whole idea of invoke dynamic is that you have a two-step invocation process. And invoke dynamic will basically just specify, instead of specifying an actual target, it will specify a bootstrap method. The bootstrap method is a method that is invoked a single time. And when you invoke it, bootstrap method is actually invoked, so you can set a breakpoint there. And for lambdas, there's a lookup ID, a class called lambda meta factory in Java lang invoke. And the meta factory is then returning an object of the type call site. Call site is basically just a handle pointing to the actual method. And it will give one of the 4 types of method invocations that is listed there above. So, for example, you can say, I will, instead of this invoke dynamic, I want to now buy invoke virtual. So what is happening then, this call site is returning this object, and then JVM knows about this mechanism. It is more or less basically deleting the invoke dynamic bytecode and is pasting in an invoke virtual, for example. And the result is that you can now at runtime decide what kind of call site you want to have and patch the bytecode in a way. It's of course not physically based. It's replaced in the invocation engine of the JVM. It will just replace this particular segment of bytecode so that the performance will be set if you had decided during, and that allows you to positions, which is basically making it possible for you to compile your code and then benefit of JVM updates. The idea is that, like Lambda methods, that everybody can, if there ever is a better way of implementing Lambdas within JVM in the future, then the JVM can just switch this out and you can still use and run all bytecode without suffering performance penalties. Because that would have been the alternative. If you emulate Lambda expressions with the current Java language constructs, like make it similar to abstract methods, like that still as animals classes, that still require allocation, then in the future you couldn't replace that without having everybody move to a new Java version, and that includes libraries and so forth. So this is supposed to make the JVM not worse on the agile in the future. So that's the whole magic. And actually, there's not only invoke dynamic, there's also constant dynamic since Java.IL, which allows you to do the same with constant values, like where you have a string before, you can now just have constant dynamic in theory and decide what constant value, like a number or so forth, you want to have at a particular site using the same approach. Right. So that's all the fuss about this. Yeah, now I have only 1 minute left, so I won't start a new topic. Cross-cutting. Okay, I read the question. You spoke about cross-cutting concerns in Spring Views, Spring AOP, and how does it compare with bytecode generation of Byte Buddy? Well, Spring AOP is using Aspect J mostly, and it's similar. It's just a different framework. It's the same. So, but the problem is with Spring AOP compared to Java Agents, for example, is that you have to use Spring. So, like, let's talk about the security feature. If you forget that you have to create an object using Spring, the security feature won't apply because you will just have your regular object. I think Spring AOP has an agent mode because Aspect J has an agent mode, so you might be able to apply it even to agents, to self-instantiated objects. But other than that, that's the difference. But no, it's the same. It's the same idea. Spring Security is a part of Spring AOP in a way. I think, yeah. No, Spring AOP just goes deeper. I think that's the thing. Spring AOP has implements more things. You can like define these point cuts and join points, so it will use the Aspect J engine. That's kind of the thing. So regular Spring Boot will only apply to your configuration beans, and yeah. But don't hold me responsible for that being right now. I would have, but it's a bit of legacy, I think. But yeah. Is there any other question? More use cases for instrumentation. So like a very popular one these days is distributed tracing, Zipkin, and general monitoring, Prometheus, automatic metric extraction. And basically what all these libraries, all these agents do is they know all the standard libraries, they know all the standard HTTP clients, they know all the standard database drivers, and then they will just extract metrics automatically by changing, like basically by adding the metric collector to the library itself. So you can just drop it in, and then it will automatically fetch all the stuff for you without you having to add the metric registry to your code and wrapping thread pools and wrapping database sources and so forth. So you can basically turn it on and off quite easily, and then you can also delay it. So you can put this into a later step of your distribution process. For example, you can have your monitoring team that adds it to all Java ads the same way, so all the metrics are consistent. So basically, yeah, that's one of the more modern ones. Yep. Any other questions? Yeah, thank you for having me. Yeah, I'd love to, but yeah, let's see. Yeah, no, then I'll go fetch my kids from school. That's the benefit of not traveling. All right, have a good conference further on, and thanks for having me. Cheers.